Hey all, good morning. Our project is based on AI enhanced sensor data quality, and we have used HTML, Bootstrap, and Chart.js, JavaScript. It is dynamically visualizes sensor data. It will calculate the quality score and allows user to interact with the data. And this is the HTML structure. Here, Bootstrap CSS is included to style the dashboard. Chart.js is used for data visualization. Axios is included, but it is not used for now, and it is used for further enhancement. It will fetch the data from API. Next comes the body section. This is the body section, AI enhanced sensor data quality. It will display the dashboard title and then overall data quality score. Here it will display the in the circular box, so the scores are updated dynamically. And then data quality analysis, it is displayed in donut chart using chart.js to show the proportion of high quality, noisy or anomalous data. Next comes live sensor data. Live sensor data, it is used for livelihood and sensing the data in the table. It will update every 5 seconds. Next, quick actions. Quick actions, it will provide buttons like filter noise, detect anomalies, export report. Next, from here on, it is JavaScript. JavaScript is generating sensor data. It will generate 10 random sensor readings between 0 to 100, and it will determine the status to classify each reading. Next, determining the sensor status. It will classify the sensor readings as if it is below 30, anomalous, red color, 30 to 59, it is noisy, yellow, 60 plus, then normal, it is green. Next comes fetching the data. Okay, fetching the sensor data, it will fetch new sensor data and updates the table, quality score, and the chart. And update table will update the sensor table dynamically with new data. Updating the chart. Updating the chart, it will update the donut chart with new data. Updating quality chart, like it is creating the chart. Here it will only create the donut chart. Next, quick access. Quick access, you will get filter noise, detect anomalies, export report. You will get alerts for noise filtering and anomaly detection. Exporting report, it is used to export the sensor data to CSV file. And then next we have to initialize the dashboard. Here the dashboard will update the data every 5 seconds, so it will be fluctuating. And from here we have come to know that the dashboard provides the real-time visualization and analysis of sensor data. It will help the users to monitor the data quality, detect anomalies, and export the output now. This is the output. This is data quality analysis. You can see high quality is green, noisy is yellow, and red is anonymous. It will be changing every 5 seconds. This score will represent overall quality of sensor data. We have given the data set here. Here you can see the data. The sensor data is converted into CSV file through export report, and there are 10 sensors. So you can see anonymous is red, yellow is noisy, and normal it is green.
This is a confusion matrix code. A confusion matrix is a performance measurement tool used for classification problems in machine learning. It compares actual versus predicted values to help evaluate model accuracy and errors. Where true positives are correctly predefined the positive cases, where true negatives are correctly predicted the negative cases. False positive are incorrectly predicted as positive, like type 1 error. False negatives are incorrectly predicted as negative, like type 2 error. The main importance of this matrix is it helps in understanding where a classification model is making errors. It is particularly useful when a class imbalances exist, for example, detecting fraud where positive cases are rare. It helps decide whether a model is better optimized for precision or recall based on application needs. This is a code. Here we install NumPy, Seaborn and Matplotlib for running. Uh, yeah, this is the output of the code, confusion matrix. The x-axis is a predictive and y-axis is the actual. Uh, The main use cases of confusion matrix is evaluating classification models in machine learning and identifying imbalanced data sets, like medical diagnosis and fraud detection. It also comparing the false positive and false negative rates to fine tune models. The confusion matrix allows us to calculate several important matrices also. In that, accuracy, precision, positive predicted value, recall, sensitivity, true positive rate, F1 score, harmonic mean and precision and recall. Thank you. Uh, This code generates a receiver operating characteristic, that is ROC curve, and calculate the area under the curve AUC for simulated binary classification model. The receiver operating characteristic curve and area under the curve are important tool for evaluating the performance of binary classification models. They provide insights into how well a model distinguishes between two classes, that is positive and negative, where the ROC curve helps evaluating binary classifiers performance. The AUC score measures how well the classifier distinguishes between positive and negative classes. A higher AUC means better classification performance. This is the code. First, we have to import the required libraries, then generate simulated data. Uh, Then compute ROC and curve and AUC score. Plot the ROC curve using figure size and plot the figures. Next, label the graph. X label, Y label and title of the graph. Yeah, this is the final output of the code. Uh, where the plot shows the orange curve is ROC curve of our simulated classifier, and dashed navy lines are the random baseline, y equals to x. AFC score is if close to zero point 0.5, it indicates random guessing, where AUC value interpretation zero point 0.5 model is random, no discrimination ability. Um, zero point 0.6 to zero point 0.7 is poor performance, where zero point 0.7 to zero point 0.8 is fair performance. From zero point 0.8 to zero point 0.9, good performance. Zero point 0.9 to 1.0, excellent performance, and 1.0 performance model is no errors, that is perfect model. The use cases of this curve is threshold independent. Unlike accuracy, ROC AOC validates model performance across all possible classification threshold. It handles imbalanced data well. Maintains accuracy can be misleading if one class dominates, but AOC provides a better measure of separability. Useful for comparing models. Two models with different probability outputs can be compared directly. Thank you.